Frequency is generated by momentum interacting with itself and surrounding. Light becomes waves, spin becomes orbits. Synchronized momentum need to disperse and interact evenly with surrounding, transforming all synchronized momentum into frequencies of synchronicity. This generates loops to interact three-dimensionally. Loops extends from the disk inner orbits to outer orbits, and back on the opposite side of the disk. As extensions from this spin, loops are significantly more flexible and dispersed than this. Proton's trajectory configuration is counter-clockwise-down or clockwise-up. Proton's absorbing side is counterclockwise. Electron's trajectory configuration is counterclockwise-up or clockwise-down. Electron's absorbing side is clockwise. Attraction. Clockwise-up proton, clockwise-down electron can connect horizontally by forming disk and loop belts, feeding on each other's momentum and recreate each other closer. Clockwise-up proton, counterclockwise-up electron can connect vertically by forming loop belts and disk vortices and recreate each other closer. In vertical attraction, both systems' disks need to be spinning in opposite direction to generate vortices. Vortices can divert unsynchronized momentum to disks and stabilize connection angle. This spinning in same direction will increase synchronized momentum and will disperse or tilt away. So electron to electron cannot attract even when loops are aligned, as their disk trajectories will not be compatible and will flip and repel. Proton-electron can rotate to connect at optimal angle. If two synchronized configurations cannot attract, their trajectories can only be conflicting and repel. Synchronized equilibrium. Proton and electron absolutely love their configuration. Sometimes proton-electrons stretch their frequency, shape, size, distribution, amount of momentum, but will always try to revert to sync equilibrium. Synchronized matter versus unsynchronized surrounding needs bridging from synchronized to unsynchronized momentum. Synchronized momentum need to disperse and adapt through unsynchronized momentum. Synchronized momentum is dispersed in pulse pattern. Synchronized equilibrium is the balanced distribution of synchronized momentum. Sync equilibrium determines the universal size and distribution of all protons and electrons, and their inclination to stay that way. Proton is maximum concentration, limited by interference. Electron is minimum concentration, limited by interaction. Belts are generated with borrowed momentum from main configuration. Conserved charge cannot generate similar overall disk and loops extensions, thus most synchronized extensions transform to unsynchronized extensions. Unsynchronized momentum of a field system is dispersed in inverse square root pattern. Combined loops. As extensions from this spin, loops are significantly more flexible and dispersed than this. So when electrons are still, loops can combine with other loops much easier than disk to disk. When molecule of electrons in a molecule spins in the same orientation, their loop extensions combine, attuning into wider loops extensions. Another magnet is inclined to rotate to match the orientation of absorption and emission. A ferromagnet has valence electrons free to rotate around. Each electron acts as a nanomagnet, orientating to the magnetic lines and then join with it. A ferromagnet or magnet moves closer to stronger magnetic field, so its electrons can better synchronize their absorbing loop to incoming momentum and emitting loop to outgoing momentum. Non-magnetic objects have electrons locked in place in counteracting orientations, where loops cannot combine and jointly decide where the object should face.